Hello, today we're going to look at day 2 of differential equations. We're still working out of section 6.2 and 6.3. So today we're going to look more and focus more on particular solutions. So it's similar to last class, but we have an initial condition. Last class we had a plus c, and at the end, because there was not a particular point that the equation had to go through, so there were infinitely many possible solutions. Today we have an initial condition, and so that means we have a point. So it could be given to us like this, y of 0 equals 10, or it could be given us as a point, 0, 10. So we need to recognize both. In general, it's usually on the multiple choice part of the exam. A particular solution is on the FRQ with an initial condition to solve for, and this process is usually anywhere from 5 to 6 points of the 9 points on the FRQ. So we're going to look at how we're going to do this, and I will tell you up front that if you plug the C in early, you're going to get a different value from if you plug the C in later, but the final will be the same. So for purpose of practice with me, I expect the C plugged in early rather than later. So just so you know, that's going to be an expectation for Miss Lou and myself that when you are finding your C, you're going to do it early. Okay, so just keeping that in the back of your mind. So if we look at the steps here to solve the differential equation, remember we separate the variables first. We integrate both sides at the same time. If there is an initial condition, then we substitute and solve for C, and then we solve the differential equation. So this is going to happen first before this. So keep that in mind as we go through today. That's my expectation for you as you're working through these problems. So it's going to be just fine. All right, so let's look at the first one, the particular solutions here. So remember, that's what we're practicing today. Last time we practiced general solutions and we had our plus C. Today we're going to get the general solution that we have, so we have a plus C. Then we're going to solve for the plus C, and then we'll have a particular solution that goes through a specific point with that initial general solution. All right, so in this particular problem, I'm looking at my work here, and I want to make note here. So this is the same thing as y10, where this is your x and this is your y, and this is your initial condition. Now, I realize as I'm giving you these to practice the process that it's very spelled out for you, but sometimes you have to actually look at the word problem itself to figure out what the initial condition is. So just be mindful that right now we're just practicing the mechanics of it. Given a differential equation, given an initial condition, what's that going to look like in the end? So we're going to separate our variables. We're going to pull the y terms to the left. We're going to pull the constant and the x terms to the right. So I'm going to have dy equals y, and then I'm going to have 3/4, and then I'm going to have dx. So we have separated our variables, and then we're going to integrate both sides. So I'm integrating here, and I'm going to pull my constant out and integrate there. So then I look to see, do I need any u sub? Do I need to rewrite anything to make something out of the denominator come up? Any of those techniques that I use to get this in differential form. I can see that I have dy over y here, so I'm ready to integrate. So I'm going to do the natural log of absolute value of y equals 3/4 x, and then I have my plus c, because at this point I haven't actually used the initial condition. So the plus c is still there. So this is the first step of what we did last class, and this would be the general form. All right, so once we have the general form, then we are going to plug in the initial condition, and we're going to find our c right now. So we did the integration, we got our general form. Now I'm going to solve for c. So remember that x is 0 and y is 10. So I have natural log of 10. I don't need the absolute value bars there because 10 is just a positive number, equals 3/4 times 0 plus c. So natural log of 10 is on this side, and over here I have 3/4 times 0, which is 0. So C simply equals natural log of 10. So now I have my C. So what I'm going to do with my C value now is plug it back in. So I'm going to come up here to continue my work. And so when I plug it in, I'm going to have natural log absolute value of y, because that's this side of my equation. And then I'm going to say that equals 3/4 x plus natural log of 10. And so now I've got to figure out how to solve for y, because remember we said when we are solving differentiable equations that means get it into y equals. So I can see on this side I have a natural log and I have the y that's trapped within the log. So I need to get rid of the natural log and I need to get rid of the absolute value bars, and we practiced this last time. So I'm going to get rid of the natural log by doing absolute value of y equals, and then I'm going to take e and I'm going to raise this whole side, 3/4 x plus natural log of 10. And that got rid of the natural log part right here. Now I want to get rid of the bars. To get rid of the bars, I need to account for the plus or minus situation that can happen with absolute value. So now I'm going to have y equals plus or minus e to the 3/4 x plus, and then we're going to have natural log of 10. So when we get to this point, we can see that we have two different equations here. The one that's y equals the positive version of this and y equals the negative version of this. And the other part that varies today between general and particular solutions is you cannot leave your answer in terms of plus or minus since you have an initial condition. So you use the initial condition to determine which one is the answer. And to do that, we just plug in. So we're going to plug in basically and check. So I'm going to plug in my x value to be 0, and I'm looking to see what's going to give me 10. So as I plug in, then I'm going to say 3/4 times 0, so that's 0, and e to the 0 in this case would be 1, but I also have this particular piece. And then I have the natural log of 10, so that's e to the natural log of 10. So remember last time we practiced splitting these up, so this is e to this part times e to this part. So as we're working through that, I'm literally going to plug the 0 in. So 3/4 times 0 is 0, and then I have e to the natural log of all of this, which is 10. So when I plug in 0, I should get positive 10. So then we want to check both plug-ins. So what if I plug in when it's positive e to all of this, and when I plug in if it's negative e to all of this? And that's what I'm going to test to see which equation to use. So when I go about plugging this in, let's start with the positive. So I'm going to come up here and say 3/4 times 0, so that's 0, and then e to the 0, right? So I have 0 right here, plus natural log of 10. So e to the natural log of 10. So this is 0 plus natural log of 10. Natural log of 10, base e, natural log base e makes this be positive 10. So then I have a y value of positive 10, which is what I'm looking for right here. If I test it in the negative, then I would be down here. So it'd be negative, and then I would have 0 here, and I would have plus natural log of 10, which is 10, but then I would have negative from the negative in front of the equation 10 instead of positive 10. So what that tells me then is once I check, I'm going to use the equation y equals positive e to the 3/4 x plus natural log of 10. And that would be where I would be safe stopping in a problem on a test. FRQ stop. Okay, so that would be my safe stop. You're not finished with the particular solution until you get to this point, till you've tested and figured out which one to use, the positive version of the equation or the negative version of the equation. So what might this look like if I went ahead and turned it into a multiple choice question once I had this? Then remember I could take y equals, and it could be e to the 3/4 x times e to the natural log of 10. And so I know e to the natural log of 10 is 10, so I could have y equals 10 e to the 3/4 x, and that could be a multiple choice type answer. So we always need to make sure we can practice both. All right, so the process isn't too bad from last time or too different from last time. So we're going to move on to question 2. And in question 2, then we are going to look at, here's our differential equation, here's our initial condition. So the first thing that we're going to do is to separate our variables and address our initial condition. So we do want to be careful. We don't want to forget the plus or minus, those kind of things. So just all the little technical things that we want to make sure that we make happen. All right, so go ahead and pause your video and separate your variables. So you've separated your variables. Do we need any U-sub or anything like that to get this ready to integrate? And we don't, so we're going to integrate both sides. And then as we go through the process of integration on this side, then I'm going to add 1 to the power of 1 here. That's 2, divide down, so that's going to be 1/2 y squared. And then that's going to equal, on the other side, I'm going to add 1 to the 2, that's 3. When I divide down, I get 1/3 x cubed plus c. So once we have our general solution, remember, then we're going to plug in to find our equation, our particular equation with this initial condition. So remember, this just means 3, -2. So we're plugging in 3 for the x and -2 for the y. So that means I'm going to have 1/2 times, and the y value is -2 squared, which equals 1/3, and the x value is 3 cubed plus c. So then we're going to solve for c. So -2 squared is +4 divided in 2 gives me 2 equals 3 to the 3rd power is 27 divided by 3 is 9 plus c. So I just found my c to be -7. So once I have my c to be -7, then I'm going to go back in and plug it in to my general solution equation, which is right here. So I'm going to have, moving up here again, so I'm going to have 1/2 y squared equals 1/3 x cubed minus 7. And so once I have, at this point in my work, I actually have 5 points of the 9 on this FRQ. So where would you get your points? You would get 1 point for separating your variables. You would get 1 point for integrating the left side correctly, 1 point for integrating the right side correctly, and 1 point for entertaining your plus c. And then you would get 1 point for solving for c. So that's 1, 2, 3, 4, 5 out of 9 points just right here. So this is why make sure we spend some time here making sure you're comfortable with that. All right, so after we do that, we need to solve the differential equation. So that means we need to get y by itself. So go ahead and pause your video and isolate y. So at this point, we're checking our values. So I'm going to put a 3 in here, and so I get 2 on top times 3 times 3 times 3 over 3. I can get rid of one of the 3's. 3 times 3 is 9. 9 times 2 is 18. 18 minus 14 is 4. Square root of 4 is 2. But what do I need according to my initial condition? I need that to be a -2. So if I do the positive version of this, I get a y of +2. If I do the negative version of this, when I get my answer of +2, then I'm going to multiply it by negative, which makes it now be -2. So that means when I am picking my equation to use, I'm going to say that my solution is y equals negative, and we're going to have that 2/3 x cubed minus 14 inside. And that's going to be the equation that earns us that last point. So we would have the 5 from here, and then probably the 6 point would come right from here, having to determine which equation to use, negative or positive. So if you forget the plus or minus and it ends up being the negative equation, you've kind of put yourself in the hot seat to be able to get to an answer. So do be careful on that one. All right, let's look at the next one. 3. So we're going to separate our variables. We are going to integrate both sides. And before we integrate both sides, it has to be at the same time. So if you need to do any U sub or anything like that, you would make that happen first. Then you find your C, and then you check. And if it's a plus or minus situation, you have to make sure that you do indeed have the right equation. All right, so I want you to go ahead and separate your variables and integrate both sides, and then check back in with me and we'll talk about that initial condition for C and then move on. Pause your video. All right, so we separated our variables, got it set up to integrate, needed a little bit of U sub to get the left side ready to go. So now I'm integrating 1/2 the integral of e to the u du equal to 3 the integral of x squared dx. Remember, I tend to pull my constants out. You can leave them in there. It's up to you. So when I integrate this side, I'm going to get 1/2 e to the u. When I integrate this side, I'm going to get x cubed plus c. Remember, your plus c is a must. All right, so now that we are here, we need to put in our initial condition and solve for C. So we're going to use our initial condition at this point. Remember that the x is 0 and the y is 0.5. So go ahead and plug in your C, plug in your x and y values and solve for C. Pause your video. All right, so how did you do? So we made our substitution in right back in here. And then we plugged in our x and our y values here. So I ended up with 0 to the third power, or just c, and then 2 times 1/2 is just 1, so that's e to the 1, so it's 1/2 e. So then when I plug my c back in right here, I've got my particular solution with the c plugged in. So now we need to solve for y. And so remember that our y is up here, so we're going to have to figure out a way to get the y out. So as I'm thinking through this problem, I'm going to have to do some isolation. So I think probably the first thing I would do right here is multiply through by 2, get rid of this 1/2 in front. And so if I do that and multiply through by 2, then I'm going to get e to the 2y equals 2, and then I'm going to get x cubed, and then I'm going to get 2 times 1/2, which is just going to be 1, so I have plus e. And so now how do I get that y out of that exponent? I change it to a log. So the output to a log is 2y equals, and I'm going to have natural log of 2x cubed plus e. Why don't I need the bars? Well, when we're integrating, right, we're just switching from forms. We're not actually integrating, so we don't really need the bars here. And then what can we do to get y by itself? Then we're going to divide everything by 2. So I have y equals natural log of 2x cubed plus e all over 2. And so there is no plus, so we don't actually have to check, but we can to see, what we're going to get, right? We could go ahead and put the 0 in for the x right here, and we should get 1/2 as an answer. So 0 cubed is 0, so that zeroes out. Natural log of e is 1. 1 over 2 is 1/2, which is what our initial condition is. So you can use that initial condition to check, even though it's not a plus minus situation where we're using it to eliminate. All right. So we're moving on to question 4. And so what I would like for you to do now is kind of try and get it all the way to the y equals. Don't go to a multiple choice option or anything like that, but we're going to go ahead and try and see how far we can get till we get to the plus or minus, and then we'll come back and check in and see how we did so far. So pause your video. We'll be right back. All right, let's see how you did. So we separated our variables, and I went ahead and simplified this. It makes it a little bit easier to integrate, because if you have 2 on top with a plus sign, that means you had 2 fractions that had a common denominator. So then I integrated the left side. I got 1/2 y squared. I integrated 1 over x, which is natural log absolute value bar of x, plus integrate 1 is x, plus my c. And then I plugged in my initial condition. So x is 1, y is -4, and I got a c value of 7, which plugs it back into the equation. And now I have to get y by itself, so I multiplied everything through by 2, and then I took the square root of both sides, so I end up with plus or minus, and I went ahead and bumped this up because if I bump the absolute value of x up to the power of 2, I can get rid of my bars because I can't ever get a negative number. So I have a natural log e to the x plus 2x plus 4. So now I'm going to use my initial condition to figure out what's going on here. So I'm going to plug in for my x. So 1 squared is 1. Natural log of 1 is 0. 2 times 1 is 2 plus 14. So 14 plus 2 is 16. The square root of 16 can be either 4 or negative 4. Which one do I need it to be? I need it to be negative 4, so I'm going to take the negative version of the equation for my answer. Okay, sorry about that. So when we're doing this particular kind of problem, we just really have to watch out and not lose sight of what we're trying to find when we're picking which equation will give me this particular y value. All right, so let's move on to 5. And on question 5, we're going to solve for C, and we would check our initial condition to determine the value of what to use if we had a plus or minus. So for time purposes on this one, we're going to go ahead and separate our variables, get it ready to integrate, find our equation, and determine what our plus C is going to be on this one. Once we do that, then we can plug back in and find the actual equation. So go ahead and pause your video. I'll check back in with you all the way at the end to see how and if we got where we needed to be. So pause your video. All right, so we separated our variables, we integrated both sides, had our plus C. We plugged in our initial condition to find C to be 2. We plugged the 2 in for the C in the general equation. Then we proceeded to solve for y. So I multiplied everything through by 2. Then I took the square root of both sides, and so I'm left with 2 possibilities. So I plug in my 0 for x. 2 times 0 is 0. 0 squared is 0, so I'm left with 4. The square root of 4 is 2, and what do I need it to be? I need it to be a negative 2, so I'm going to use the negative version of the equation to pick as far as my particular solution. So we're moving on to 6. So 6, we have the differential equation. We're going to separate our variables, integrate both sides, find our C, plug the C back in to get a particular solution, and then solve for y and test with our initial condition if we end up with any type of situation where there's a plus or minus or more than one possible solution. So go ahead and pause your video and we'll check back in. All right, so let's go through this one right here. So we separated our variables, we integrated both sides, we plugged in our initial condition to find our C value, which ends up being the natural log of 7. We plug that back into our general solution where the C is to create this equation. And then to solve for the differential equation, we need to get y by itself. So to get rid of the natural log, I raise it to the base of e. Then to get rid of the absolute value bars, I make it plus or minus. And so here's what I have. I can't leave a plus or minus equation. I have to pick one on a particular solution. So I plugged in 0 for x. So 0 squared is 0. It makes all of this 0 out, which leaves me with e to the natural log of 7. The base for natural log is e, so that is 7. And so what do I need it to be? I need it to be positive 7, so I'm going to keep the positive version of the equation. And then we could also remember that this e to the natural log of 7 could come down and be the constant of 7 in front. So we probably should practice that some so we can make sure we could do that when it shows up, if it shows up on any multiple choice question, okay? Okay, so moving on to 7, again, we're going to separate the differential equations. We're going to integrate both sides. We're going to use our initial condition to solve for C and write our equation. Once we write our equation, we solve for y, and if there's any situation where we have y equals 2 possible equations, then we plug the initial condition back in at that point to see which equation we need to use. So go ahead and pause your video and take care of question 7. Okay, so we separated our variables. We needed u sub on this side, so we had to rearrange this before we could actually integrate, because remember we have to integrate both sides at the same time. So then when we integrate the dy over y, we get natural log of y. We have the 1/2 for the constant that was left after we canceled the x's here, so we have that 2 in the bottom. And then when we integrate sine of u, we're going to get negative cosine of u, and then we have our plus c. So rewriting this negative 1/2 cosine, you can put parentheses around the x to the power of 2 if you want or not, as long as you understand what's being squared here is x, not that this is cosine x times cosine x. Then we put in our initial condition, so we ended up with c equal to 1/2. We plug that back into our equation right here for my c, because we were looking right here at that. And then from there, we have to get y by itself. So I raised it to the power of e to get rid of the natural log. I moved it to plus minus to get rid of the bars on the y, and now I have to figure out which equation. So when I put in a 0 here, I get cosine of 0, which is 1. 1 times negative 1/2 is negative 1/2. Negative 1/2 plus 1/2 is 0. E to the 0 is 1, and so I need the positive equation because I want to keep that positive 1, not a negative 1, so that's the equation that I'm going to use. All right, so I'm hoping you're feeling pretty confident about these equations and this process right now. So let's go ahead and pause our video and do question 8 all the way down to a y equals equation. So remember, if you have a situation where you have a plus or minus, then you have to use your initial condition one more time at the end to see which equation to use. Go ahead and pause your video. All right, let's see how you did. So we separated our variables. We needed a u sub for this part, so we got it set up and ready to go. I pull my constants out in front. So then when we integrate this side, we get negative 3y. When we integrate this side, we get 1/2 times, and then the integration of sine u is going to make me have negative cosine u plus c. Plug my u back in. So now I'm going to test for my initial condition and find c. Or sorry, not test, use my initial condition to find c. So I plug it back in here, and I know that cosine of 2 pi is 1. So negative 1/2 times 1 is negative 1/2. And so when I'm moving it over, I have to get a common denominator. And so when I move this negative over, I have negative 3 plus a positive 1/2. So I get my common denominator. That ends up being negative 6 over 2 plus 1/2. So that's where I get the negative 5/2. Then I go back into my general solution and replace the c with negative 5/2 and solve for y. And in this case, I did not have a plus or minus that I needed to check for. This is the equation for the differential equation, but I can always check. And when I plug in my initial condition here, I end up with a y value that should check out. So it is still possible to check. It's just not necessary to plug in because you don't have to like determine if it's a plus or minus, or if you have one of two values to have to pick from, like you do over here when it's plus or minus. All right, let's move on. So step 1, as always, is separate your variables. So we're going to separate our variables here and then integrate both sides, use our initial condition to find c, plug c back into the general equation to find your new equation, and then determine what you need to do to end up and finalize it with a y equals equation. So pause your video, we'll check back in. Okay, so we separate our variables, we integrate both sides, we don't need any u sub or anything like that. So we get our general solution to be negative y to the negative 1 equals 1/4 x to the 4th plus c. Plug in our initial condition, and so we find that c is going to be negative 5. Plug negative 5 back into the general equation, so you have this equation here. And then you need to combine it because I need to solve for y. So a algebra tip, if you remember from Algebra 2 or maybe in any other algebra class, I'm not sure. But if I can get this together to be a single fraction opposite 1 over y, then I can actually invert both fractions because that would be the same thing as multiplying and then dividing out. So I can get this to be y equals 4 over negative x to the 4th plus 2. We don't have any plus or minus situations. We could plug in the x value of negative 1 over here and make sure that it equaled 1 for my y value to check my algebra if we wanted to do that. All right, moving on to question 10. So question 10, remember we're treating this as a quantity together. Same thing, separate the variables, integrate both sides, plug in the initial condition to find C, plug in C into the general equation, and solve for Y. All right, pause your video and let's finish this last practice problem before we move on to the last three questions here. All right, let's see how you did. So we separated our variables, we got the sides ready to integrate. I needed a u sub over here, so I now have negative integral du over u and 3 dx on this side. So then I apply my integration rules. On this side, I got 3x plus c. So now I plug in my u sub back in right here, so I have my equation. Then I need to plug in my initial condition to figure out that c is -1. And then I put that back into the general equation, which I had down here. So now I need to solve for y. So I divided both sides by negative, which makes this side now negative 3x minus 6. I took it to the e to get rid of the natural log. I took it to the plus minus e to get rid of the bars. And then I had to move the 4 over, which would make that a -4, and then I divided everything through by -1, which makes that +4. And then I have to test my values. So when I plug into here, I get e to the 0 plus 4. So that means I need the -1 because on my initial condition, I needed to make sure that that was going to work out. So needed the negative equation. So we've done a lot of practice on the skill. So hopefully that will work in your favor. So let's look at these last couple. They're written a little differently, more in context than just the practicing the skill. So as I'm reading through this, I see if dy dx equals 2y squared and y equals -1 when x equals 1, then when x equals 2, what does y equal? So that's my first read through. My second read through, then I would be looking for what is it trying to tell me here? So when it says y equals -1 when x equals 1, this is another way that the initial condition could be written. So you can think of that as the point 1, -1. And then we have a differential equation here, so we know we're good there. And then it says, then when x equals 2, what does y equal? So in the end, it might not just be finding an equation, but we're finding, in this case, an equation because we want y equals, which is going to produce the equation. So they didn't say solve the differential equations, so you don't have to actually isolate y. They're asking you what is the y equals. So we're going to separate our variables, integrate both sides, plug in our initial condition to find our c, and come up with that equation. And then we'll do the last part about what do we do with that x equal 2. That's a little different than the way questions have been worded up to now. So go ahead and pause your video. All right, let's see how you did. So we separated our variables. We got ready to integrate both sides. We didn't have to do any u substitution or any of that. I went ahead and rewrote as I went to this next step. So I integrate the left side, integrate the right side. Don't forget my plus c. Then I plug in my initial condition. I went ahead and rewrote this and got rid of that negative exponent because I don't like to carry negative exponents through. So I went ahead and rewrote that side from the beginning. Plugged in my initial condition and found my c value to be -1. Then I went back into my general equation and I plugged in the -1 for c. But right now it's not asking for me to solve the differential equation, so it's not asking me to get y by itself in an equation like we practiced in all of these when we were practicing the skill. So it says when x equals 2, what's y? So I just took my equation and I plugged in 2 for the x and simplified it down. So I ended up with -1 over y on this side and 3 or 3 over 1 on this side. Because I have these two, I can divide, move that negative sign over, and then I'm going to get y equals -1/3. All right, so we are almost through here, guys. We have two more problems. So let's look at number 12. So we're going to find f of x by solving the separable differential equations. Goodness, excuse me. And here's the equation they give me. It has an initial condition of this. So remember, that's the same thing as 1, 3 when I'm thinking about my plug-in. So what are we going to do in this particular equation? We are going to solve the differential equation. So that means we do need it to be y equals. All right, and so we can say y equals f of x is the function that we're doing, and that makes us be able to solve y equals. We have our initial condition, so we know that we're going to plug it in and find our values. So go ahead and separate your variables, integrate both sides, solve for your y equation. Pause your video. Okay, let's see how you did. So here's my equation. So I separated my variables. I integrated both sides, got this side ready by bringing that negative or that x to the 2 up to be x to the negative 2. And I integrated this side. That's just the natural log rule. And over here, I'm going to have negative x to the negative 1 plus c. Then I plug in my initial condition, and I find that my c is an interesting value of natural log of absolute value of 3 plus 1, or natural log of 3 plus 1. And so I plug that back into my general equation right here. So now I have a particular solution, and then I need to solve the differential equation. So I need to get y equals. So I got rid of the natural log by raising this side to base of e. I got rid of the bars then by making it plus or minus to my e on this side. And then if I have the plus or minus, I have to decide which equation to use. So I plugged in a 1 for the x, and I get negative 1 over 1, and then I get natural log of 3 plus 1. So to actually get the 3, so I'm plugging in and evaluating that, and that tells me that I need it to be a positive. I need it, well, it's a negative, so I need it to be a positive, and so I'm going to end up with the positive version of this equation. If you solve it and use the determination here, f of x, then you can say f of x equals the positive equation. And if you turn it in, you can say y equals f of x. And so then you could actually turn that into this equation. So we're kind of looking at both of those. And I think a lot of it depends on how is the question worded, what are and what are they asking you, that kind of thing. All right. So let's look at the last one, question 13. And on question 13, we're looking for, we have a differential equation, and we have y equals 2 when x equals 3. Then when x equals 2, what does y equal? So we've practiced one like this before. Again, it doesn't explicitly say to solve the differential equation, so it would be easier to plug in early when you're doing that problem. So let's go ahead and see what you can do with it. Go ahead and pause your video one last time. All right, let's look at this last problem. So we separated the variables, we integrated both sides, we plugged in our initial condition to figure out that c is going to be natural log of 2 minus 9. We plugged that back into our c for our equation right here, so that's your c, and that gives me my equation. Then it doesn't actually say solve for y, but I think it's just as easy to do that because I'm going to end up plugging in for 2. And if I plug into an equation that's already in y equals form, then I have my y answer, especially if it ends up being kind of a wonky one like this. So I go to get rid of my natural log. I raise to a base of e, then plus or minus to get rid of the bars around the y. Then I plug in my initial condition, and here's what my y equals. And so when I test my value to figure out which one I need, and I'm plugging in up here, I end up with e to the natural log of 2, which is just 2. So I want the positive version of the equation. So here is my positive version of the equation. And then I need to figure out when x is 2, what's y? So y equals what? So I just went ahead and plugged the 2 in at this point. So 2 cubed is 8. So I get 8 over 3 plus natural log of 2 minus 9. So all of that is my y. So when my x is the 2 from here, this is the y as a result of plugging 2 in for x. So I just wrote it as a coordinate point. So thinking along the lines of what might this look like in a multiple choice question. And so in a multiple choice question, you could do this. They might put these two things together and, come up with something like that. They might simplify down so they're dealing with the radical of 3 at one point. So there's all different kinds of ways that this could happen. So I'm just going to give some multiple choice statements here that I think are a possibility. Like it could say 2 and then end up with 2e to the negative 19 thirds. That could be one possibility. They might even take that further and have 2 and then have 2 over root 3 e to the 19th. So, I mean, there's lots of ways we can split this up. This could be e to the 8 thirds times e to the natural log of 2 times e to the negative 9 and brought it together from that. So just food for thought and thinking about other ways that you can do these problems and get where you need to be. I really need you to do your check for understanding worksheet. Make sure you're practicing these problems. We have completely taken care of all of the strategies we need to use. We are going to be looking at a circuit training next time that deals with differential equations, and then we'll be looking at slope fields, and we'll actually be finished with this whole unit. All right, guys, thanks so much. Bye.